So in this video, we're going to look at writing the formula of ionic compounds. Ionic compounds contain metals, which you'll find on the left-hand side of the table, and a non-metal, which you'll find on the right-hand side. Hydrogen here in the middle is also an example of a non-metal. So if I had sodium bonding with oxygen, that would be an ionic compound. Ionic compounds contain ions, and ions have charges. To write the formula of an ionic compound, you must get those charges to balance. To do that, you need to know what the charge on the ion is, but this is easily worked out using your periodic table. If your element is in group 1, it's going to have a +1 charge. If your element is in group 2, it will have a +2 charge. In group 3, it will have a +3 charge. So you'll notice that the groups that are metals always have a positively charged ion, 1, 2, or 3, depending on the group they are in. These elements here in the middle are also metals, and they also form positive ions, but you cannot work out the actual number of that charge using the periodic table alone. So we'll come back to that later in the video. On the right hand side of this line, I've got my non-metals. Non-metals always form ions with a negative charge. If it's in group 7, it's -1, group 6, it's -2, and group 5, it's -3. The group 4 elements don't form ions. The group 0 elements do not either, because they already have a full outer shell. If I have potassium, the charge on the ion is going to be +1. If I have phosphorus, the charge on the ion will be -3. So a question you could get asked in the exam is write the formula of a magnesium ion. You go to your periodic table, you find magnesium, you see the symbol as Mg, you see it's in group 2, therefore has a +2 charge. And the formula of a magnesium ion would be Mg with a +2 charge. Formula of a phosphorus ion would be P with a -3 charge. Once you can work out the formula of your ions, you can use this to write the formula of ionic compounds. So if we have a look here, we're going to see some examples. So these are all names of ionic compounds. The metal always comes first, the non-metal comes second. The metal appears as it does in the periodic table, but the non-metal has changed to I, so sodium chloride instead of sodium chlorine. To write the formula of sodium chloride, I go to my periodic table. I see that sodium has a symbol Na, and I see it's in group 1, so it has a +1 charge. Chlorine has a symbol Cl, it's in group 7, so it has a -1 charge. My charges must balance. I've got +1, I've got -1. These charges do balance. So to write the formula, I leave the charges out and just write NaCl. Your final answer should not contain any pluses or minuses. You may see this and think back to my previous video where I said chlorine is always diatomic. It's always written as Cl2. That is true when chlorine is an element. So if chlorine was by itself, if you had a flask with chlorine and nothing else in it, and it's by itself, instead of existing as individual chlorine atoms, the chlorine atoms pair up and form Cl2 molecules. But in this case, you do not have a flask of chlorine by itself. You've got chlorine after it's reacted with sodium. It's no longer an element, it is now part of a compound, and we do not apply the diatomic rules when we have got compounds. All of these are examples of compounds, so we're never going to be looking at whether or not it's diatomic. That goes out the window when it's bonded to something else. Next example I've got is magnesium iodide. Magnesium is in group 2. It's got a +2 charge. Iodine is in group 7. It's got a -1 charge. These charges do not cancel out. I've got 2 positives and only 1 negative. To make them cancel out, I'm going to need 2 negatives to balance out those 2 positives, and I do that by adding a small number 2 after the iodine. Again, in my final answer, I don't have a plus or a minus, and essentially what I've done here is I've crossed the numbers over. The 1 that was next to the iodine is now here next to the magnesium. I've only got 1 magnesium. The 2 that was next to the magnesium is now here next to the iodine. I need 2 iodines. Aluminium oxide. Aluminium is in group 3. It's got a +3 charge. Oxygen's in group 6. It has a -2 charge. Again, these charges don't balance. So I write down the symbols exactly as they are above. Across the numbers over, I do not bring the signs. So the 2 that's next to the oxygen is now here next to the aluminium. The 3 that's next to the aluminium is now here next to the oxygen. I do not bring down the signs. And now I've got 2 aluminiums, which means I've got 2 + 3s. I've got +6 in total. I've got 3 oxygens, which means I've got 3 -2s. I've got -6 in total. +6, -6, my charges balance. The next one I'm going to get you to do for yourself. So I will tell you that aluminium has a +3 charge, chlorine has a -1. Cross it over, write the formula of aluminium chloride. So the answer here is AlCl3. The 3 comes down next to the chlorine, the 1 will be next to the aluminium, although you don't need to write it. And again, I do not bring down the signs. Lithium sulfide, I will tell you that lithium is in group 1, so what charge will it have? Sulfur is in group 6, so what charge will it have? So lithium has a +1 charge, sulfur has a -2 charge. Once I know that, I cross the charges over, and I get Li2S. That is my formula for lithium sulfide. The next example, lithium sulfate, is a little bit different. So far, every compound we've looked at has ended in IDE. So the metal comes first, the non-metal has the ending changed to "ide." But in this case, the non-metal has had its ending changed to "ate." So how does this differ? Lithium sulfide, lithium sulfate, what is the difference? Well, we can see from the name that I definitely still have lithium in there. So lithium has a +1 charge, it's in group 1. And I know I've got sulfur because I've still got the sulf. But instead of sulfide, I've got sulfate. And the 8 means I've got oxygen present. So instead of just having one non-metal, I now have sulfur and I've got oxygen. This is what's known as a polyatomic ion. Polyatomic, poly means many, atomic is atom. So I've got many atoms in the same ion. And unfortunately for this one, there's no way around it. You just need to learn the formula of sulfate. So I can work out from the name that I've got sulfur and oxygen, but I've actually got sulfur with 4 oxygens. And there's no way to know that other than just learning it off by heart. Because it's an ion, it has to have a charge, and the whole thing, the sulfur with the 4 oxygens all together, has a charge of -2. And again, no way of knowing that other than learning it off by heart. So sulfide, just 1 sulfur, S with the -2, I work it out using the normal way, but sulfate, a sulfur, 4 oxygens, a -2 charge overall, and you're going to have to learn that off by heart. But once I have that written down, the formula process is the same. So I write down my lithium, and I write down my formula of sulfate, which is SO4. I don't cross over the plus and the minus, I just cross over the number. So the 2 that's next to the sulfate is going to come down here next to the lithium, and lithium sulfate is Li2SO4. Unfortunately, sulfate is not the only polyatomic ion you're going to come across. You've got 5 that you need to learn. So as I said, 8 means oxygen. So sulfate is sulfur and oxygen. Nitrate is nitrogen and oxygen, and carbonate is carbon and oxygen. But you need to memorize these actual formulas with the numbers and the charges. You've also got hydroxide, which is oxygen and hydrogen, and a -1 charge. And then ammonium, which comes from, so ammonia is NH3, ammonium is NH4+. And again, you just need to learn those off by heart. There's no way of working them out. So we'll come and do a few more examples. I've got calcium oxide, so this is just calcium with a +2 charge and oxygen with a -2 charge. Okay, I know there's only 2 elements present because it ends in "ide." In this case, +2 and -2, the charges immediately cancel, so I don't need to do anything with numbers. I just write CaO. The next one, calcium hydroxide, okay, it's got calcium with hydrogen and oxygen, so I've got 3 elements in this case. So calcium, hydrogen, and oxygen. And again, you just need to know that the formula of a hydroxide ion is OH-, and you're just going to have to learn that off by heart. So hydroxide is OH with a -1. Calcium's in group 2 and has a +2 charge. And this one here is slightly different. Charges don't balance, I can see that. So I'm going to write down the formulas underneath, Ca and OH. The 1 I would be bringing across here next to the calcium, but I don't need to write it. The 2 I'd be bringing down here. But if I do this, CaOH2, what that means is I've got 1 calcium, 1 oxygen, and 2 hydrogens. But according to my charges, I don't just need 2 hydrogens. This whole hydroxide comes as 1 species, and I need 2 hydroxides. So for that to happen, I'm going to need to add a bracket around the whole hydroxide. And now this 2 refers to the whole hydroxide ion, not just to the hydrogen. So I've got a +2 charge from the calcium. I've got a -1 charge from the whole hydroxide, but now I've got 2 of them. So +2 from calcium, and I've got -2 from the 2 hydroxides. Next ones I've got aluminium nitride and aluminium nitrate. I'm going to get you to do this for yourself. So aluminium nitride is Al +3. Nitrogen is N minus 3, so group 3 and group 5. Aluminium nitrate, again, it's aluminium, nitrogen, and oxygen. You would need to learn off this formula. Aluminium is, again, Al plus 3. Nitrate is NO3 minus 1. So have a go at writing the formula of aluminium nitride, and then have a go using aluminium nitrate. So I've done the answers here. On this side, plus 3 minus 3, charges cancel, no numbers required, just ALN. Over here, my charges do not cancel. I need to bring the 3 down to the other side of the NO3, but I need 3 nitrates. So I need to put the nitrate ion in a bracket, and then I add my 3. Okay, make sure that you keep the formula exactly the same. So the NO3 cannot change, that cannot be touched. All you can do is bring the number next to the charge down. The formulas don't change. Lithium nitrate and lithium nitride. I'm going to get you to have a go at those two completely by yourself. I will tell you that lithium is in group 1. The nitrate ion you'll find over here. Again, lithium is in group 1, and for nitride, you've got just nitrogen by itself, which is in group 5. So use the groups to work out the charges on the ions. Once you've got the ions, write the formulas. So I've got the answer here. Lithium is +1, nitrate is -1. The charges cancel, so that's your answer. Lithium here again is +1. Nitride is just nitrogen by itself. It ends in IDE. It's in group 5, therefore it's got a -3 charge. Cross the numbers over and I get Li3N. The next two contain copper, which is one of your transition metals. So we said earlier that you cannot work out the charge based on the position in the periodic table. But I do know that these guys are all metals, and if they're metals, they must be positive. So if I look at the actual name, it says copper 2 sulfate. So I go to the periodic table, I see that copper has a symbol Cu. I know it's a metal, therefore must have a positively charged ion. And then the 2 in Roman numerals tells me that it has a charge of +2. So it's Cu +2. Sulfate, sulfur and oxygen. So it's one of my polyatomic ions, and it has a formula SO4 - 2. Just need to learn that off by heart. So +2 - 2, they immediately cancel. The formula is just CuSO4. I want you to have a go at the other side here, copper 2 sulfide. Copper, again, you can work out the formula using the Roman numerals. And then sulfide, sulfur is in group 6. So what charge will it have? Work out the formula of the ion and then work out the formula of copper 2 sulfide. So copper, again, 2 in Roman numerals, it's Cu +2. Sulfide, in group 6, -2 charge, +2 - 2 cancel, you get a Cus. Important with transition metals to pay attention to the Roman numerals. Sometimes copper has a +1 charge. If it did, it would have a 1 in Roman numerals and not a 2. So just look at the number and it will always be positive because it's a metal. You've got 2 more to do for me here. They both contain carbonate. Again, that's one of your polyatomic ions, the carbon and the oxygen. So I'll give you the formula of the carbonate, CO3 - 2. But you should be able to work out the formula of a sodium ion and an aluminium ion yourself. Sodium is in group 1, aluminium is in group 3. Work out the charges of the ions and then the formula of the ionic compound. All right, so these are your answers. Sodium's in group 1, +1 charge. Cross over my charges, I get Na2CO3. I don't need a bracket here because I don't need to multiply the CO3 by anything. On the other side, I do need a bracket because I need to multiply the CO3 by the 3 from the aluminium. I also need to bring that 2 down from the carbonate next to the aluminium, and I get Al2CO3 in a bracket times 3. Briefly, once you can work out the formula of an ionic compound, you should be able to complete the following equations. So in all of these examples, I've left out the formula of an ionic compound. You just need to fill it in. So I've done hydrochloric acid for you as HCl. I've asked you to do potassium oxide and potassium chloride. So I will just tell you above that potassium is in group 1 with a +1 charge. Oxygen is in group 6 with a -2 charge. Again, potassium +1, chlorine -1. So I'm going to get you to fill those in. And then down here, lithium is group 1, bromine is group 7, lithium group 1, chlorine group 7. So again, just press pause, use the charges I've given you to work out the formula of those ionic compounds and complete those equations. All right, so I filled in the answers for you there. I'm just crossing the numbers over just like we've done above. If these equations aren't balanced, you would then need to go back and balance. I'm just not going to do that here. And then have a go at the last two. So again, something similar. This time though, I'm not going to tell you the charges. You'll need to look at your periodic table. I will just tell you the groups. So magnesium is in group 2. So what charge will it have? Oxygen's group 6, magnesium's group 2, chlorine's group 7, magnesium's 2, oxygen 6, and then magnesium sulfate. Magnesium is in group 2. The sulfate ion, sulfur and oxygen, is the SO4 minus 2 ion. So using that information, work out the charges and the ions, write the formulas of the missing ionic compounds. All right, so I fill them in. Magnesium oxide is MgO, plus 2 minus 2 is the charge from group 6 elements. They cancel, you're left with MgO. Over here, plus 2, you'd have minus 1 from a group 7, so you end up with MgCl2. MgO again, and magnesium sulfate. Magnesium's plus 2, sulfate is minus 2. They immediately cancel, you're just left with MgSO4. So in the next video, I'm going to be doing more of this. I'm going to be just looking at word equations, and we're going to convert word equations into symbol equations by writing the formulas of elements, of covalent molecules, of ionic compounds, whatever is required, then going back and balancing and also adding in those state symbols.